In Lesson 82, we'll be discussing the evaluation of functions and also domain and range. Now, to evaluate a function, we learned about how to do that way back in Lesson 28. And let's just go ahead and do some practice problems. These problems will just basically be a little more complex than those. Remember that functional notation, like in practice problem A, f of x, that's how you say that. If f of x, a function of x. That's not f times x or anything like that. It's just a symbol. We could use it like a y or some other variable, but it helps us to keep up with the value that we're placing on that particular function. So we say if f of x equaled x squared plus x plus 3, find f of 2. So we just substitute 2 in for x everywhere there's an x. And so we say f of 2, and the best thing to do is just rewrite the function with the new value that you're trying to evaluate with right underneath the original function. So then we'd have 2 squared plus 2 plus 3. And then that will equal 4 plus 2 plus 3, or 4 plus 5 is 9. And so that's what that equals. F of 2 is equal to 9. Now let's use the same function and let's find out what f of a is. Now try not to get confused on this. All you do is substitute a in everywhere there's an x, just like you just substituted 2 in everywhere there was an x to find f of 2. This time you won't get a one number answer. It'll be a list of variables. It'll look like the original expression. So let's just go ahead and write down the original expression. F of x equals x squared plus x plus 3. Right beneath it, let's put f of a. Substitute an a in everywhere there's an x. So you just say a squared plus a plus 3. It's just that simple. That's all you do. That's your answer right there. You have evaluated that function for f of a when x equals a, basically. Let's go one more step. Find f of x plus 2. And so now everywhere there's an x, we change that and put x plus 2 in there. And x plus 2, that's a sum, so we think of that in parentheses. We always put it in parentheses every time we insert it into the function. And so we will say f of x, let's write down the original expression, is equal to x squared plus x plus 3. Now we're going to put in f of x plus 2. And so everywhere there's an x on the right side of the equal sign, that changes to x plus 2. And we have to square that whole thing. We keep it in parentheses. And then we'll say plus parentheses x plus 2 and then plus 3. Now we need to simplify this, so we need to expand out that x plus 2 squared. And so that'll just be x plus 2 times x plus 2 plus x plus 2 plus 3, or just x plus 5. Let's go ahead and expand those binomials. X squared plus 2x plus another 2x plus 4 plus x plus 5. So now let's go ahead and simplify that expression. And we'll start out with x squared. And then we have a 2x, and an x. So those would add up to 5x. And then we'll add the 4 and the 5 together to get 9. And that's what f of x plus 2 is equal to. So when you evaluate a function, that's what you do. You just, whatever is inside the parentheses right after the f, or it could be an h of x or z of x. F is just one of the symbols that's used. Whatever you have there, you just substitute that in for x in the function. And that's what evaluating functions is. You don't necessarily get a numerical answer. You may have letters and numbers or just letters for an answer. It depends on the type of function. And also what you are evaluating it for, what you're substituting in for x. Now in 82B, we'll apply what we understand right now about functions to a concept called domain and range. Now first, let's just start out with a linear equation, like y equals 2x plus 1. Now I've talked about this before, but it's been a while. That y value, we could just replace that with the function symbol, f of x equals 2x plus 1. So f of x, that function symbol, it's the same thing as thinking about y. And so like even on a Cartesian coordinate system, we could call this the x-axis and this the f of x axis instead of the y-axis. Like if you were making a table, an xy table, you could have an x and an f of x table instead. And so you could say when x is equal to 1, f of 1, that would be 3, and so on. So when you think of f of x as part of an equation, just think of that as y. All it is a symbol to represent a variable. Now so far all we've talked about as far as functions is that notation, but there is a specific definition for a function, and basically a function is an equation that you can graph on an xy axis. Now there's some special words that are used when you're talking about functions, and for example the notation, instead of a y you use an f of x symbol or something else with the x in parentheses. The x values that you use and the y values that you use, they have special names. The x values, or the set from which the x values come from, is called the domain, and the y values are called the range. And this is a set of numbers, so think of it as a set. And I'll even use little brackets so we can think of it as sets. The domain, those are the x values that go with that function. The range, that's the y values, or f of x values that go with the function. Now in a function, each x value or each member of the domain has exactly one y value or one member of the range set that it corresponds with. For example, in our function above, f of x equals 2x plus 1, when x equals 1, f of x equals 3, and there's only one value that that number 1 in the domain corresponds with in the range, and that's a 3. It doesn't correspond with a 4 or 7 or anything else. So one thing that you're going to be doing here is you'll be given a function and they'll ask you to maybe find the domain and the range, or just one thing, just the domain or just the range for that particular function. Let's just start with y equals 2x plus 1, and real roughly we'll graph y equals 2x plus 1. It would probably go through this xy axis above, something like that. And it's a line, so it continues on forever in both directions. And so its domain, that's the set of x values that you could put into that function and still make it a true function. Well, just think about it. It's going to go on forever horizontally, right? Because it'll just continue on down, on down, on down. So it'll be moving to the negative x direction and the positive x direction. So the domain would be all real numbers for that. And the range would too, because it's going to be increasing vertically and in the positive and negative y direction. So its range is all real numbers as well. So what we would say for an answer down here at the bottom, we'd say the domain of f equals, and we could just use this symbol right here. It's kind of a strange looking R. And that means the set of all real numbers. We do the same thing for range. We could say range of f is equal to all real numbers as well. So for a function, the domain is all the x values that can work in that function, and the range is all the y values that will work in that function. In a function, each x value, it has exactly one y value that it corresponds with. Now let's go ahead and do some practice problems where we have to find the domain and range of different functions. What I have here graphed on this Cartesian coordinate system is a type of function. Now remember, a function is just an equation that can be graphed on the xy axes. And to be called a function, every x value or member of the domain corresponds with or is mapped to exactly one y value. So the domain for this function, that means all the x values that would work in that function. And the way you figure that out is you just look at it horizontally. And so look at the farthest left point that it goes to, and that would be right here. And the farthest right point that it goes to would be right there. And so we just look at in between those 2 points. Those are the acceptable values for x. That's the domain for that function. This is how we write the answer, and this is going to look pretty strange, but this is just how you do it. Domain of f, and I'll call it f because see, I have at the top of that Cartesian coordinate system f of x, so we'll call this function f, equals, then we put like a big brace, then we write x is a member of, that's what that symbol means, remember? It's a member of the set of real numbers, and then we put a bar. That bar means such that. X is a member of the set of real numbers such that, and now we have to compare the maximum and minimum values for x. And so let's put x in the middle. We'll have an inequality, right? X is going to be less than or equal to positive 3 because we have that closed circle there at positive 3. So it's less than or equal to positive 3, and it will be greater than negative 2, not equal to it because we have an open circle at negative 2. So we'll say greater than negative 2, closed braces. So reviewing that, x is a member of the set of real numbers. This little vertical bar there, that means such that. And then we have an inequality there to describe the domain of x, or the domain of the function. Now let's figure out the range of the function. And so what we need to do there is think vertically now. The range goes with the y values, so we think of the lowest point and the highest point. Here's the lowest point right here, and here's the highest point right here. So our range is in between those 2 points. And so we'll say the range of f is equal to y such that y is a member of the set of real numbers. Got a little ahead of myself there, and we kind of make that double vertical bar there on the r. Y is a member of the set of real numbers such that, now our range is from 0, and that would include 0 right there, to a positive 4. And so we'll say y less than or equal to 4, greater than or equal to 0, close brackets. So that's the domain and the range for that function. Domain is the set of acceptable x values that will work in that function. Range is the set of acceptable y values that will work. Look at problem E. I want you to find the domain for that function. I went ahead and wrote it f of x equals the square root of 3 minus x just because we're working with functions, so you know that this is a function. Now, you're going to have to think about this a little bit. You're going to have to substitute some numbers in there to see if they work or not. This is a square root, so you can't have a negative number inside the square root. So that'll be a limit to your acceptable x values or your domain for your function. That's what we're trying to do here, is figure out what the domain is. So think of some numbers. Just like put 1 in there. Square root of 3 minus 1. That would equal the square root of 2. Let's try 3. The square root of 3 minus 3. That would equal 0. Let's try 5. The square root of 3 minus 5. That equals the square root of negative 2. Now we can't do that. We can't have the square root of a negative number. So 5 would not work. 5 cannot be used as the domain for that function. Now think about it. 4 wouldn't work either. 3 is the limit. And actually the numbers have to be equal to 3 or less in order to work. So let's go ahead and write down what the domain is. We'll just say f equals parentheses x is a member of the set of real numbers such that x is less than or equal to 3. Close parentheses. And I should put domain over here as well. So on a problem like that, it's real important to substitute some numbers in and see what works and what does not work in that function. Let's do another one. Find the domain and range of that function. H of x is equal to 7. Well, remember, a function like h of x is the same thing as saying y. So basically we're saying y equals 7. That's our range. It's just 7. That's all we can put in there. No matter what value of x we put in there, the y value will always be 7. Just think about it. It's like making, if we make a little xy axis and we could draw y equals 7, that would be a horizontal line. So it has all kinds of x values but only one y value. So I'm just going to do a little shorthand here. I'll say D for domain of H. That is going to be equal to x is a member of the set of real numbers. And there's no such that or anything. It's just a member of the set of real numbers. Or we could just say, put an R in there instead and just say the domain of H is the real numbers. The range for it, we can say range of H is equal to basically just 7. That's the only number that will be in the range is 7. So the domain, that's all the x values that will work for a function. The range is the set of all the y values that will work in that function. Okay, well that's all for lesson 82.